Okay, for the second FRQ, we have a differential equation, and we want to show that the second derivative is that. So let's do it. Starting with this right here. So if we take the derivative all the way through implicitly, derivative of dy dx is d squared y over dx squared equals derivative of -1 is nothing, so that goes away. And here we have quotient rule, so we have the derivative of the top, which is 2y dy dx times the bottom minus derivative of the bottom, which is 1, times the top, which is y squared. And this is all over the bottom, or denominator to be more mathy about it, x squared. Okay, so d squared y over dx squared equals 2y, well, dy dx, we have it, that big thing. So times -1 plus y squared over x minus, well, 1 times y squared is just y squared, all over x squared. D squared y over dx squared equals, well, oh, I lost my x. Lost my x. There should be 2yx right there. All right, there we go. Multiply it through. 2yx times -1 is -2yx. I'm going to say -2xy because it's, alphabetical and looks better. If we multiply 2xy times y squared over x, the x's will cancel, and we'll end up with plus 2y cubed, and then we have minus y squared, and this is all over x squared. If we change the order in the numerator, d squared y over dx squared, we'll get, if we go in descending power order, more of a standard form, 2y cubed minus y squared minus 2xy over x squared. I only changed the order so it would look like what we wanted to get. There it is. You might hear a page in the background. Here's the second part. We know that y equals g of x is the particular solution to our differential equation. We have our initial condition 4, 2, so that's a point. We want to know if g has a relative minimum, a relative maximum, or neither at x equals 4. So the instinct might be to integrate and actually try to find what y equals g of x is, but we don't need to because we're just talking about critical points. We get that from a derivative. So essentially, in order to have a critical point, the derivative has to be 0. So let's see if the derivative is 0 at 4, 2. dy dx equals -1 plus, well, y is 2, so 2 squared, x is 4. And this is -1 plus 2 squared is 4, 4 over 4 is 1. So this equals 0. So it must be a critical point. I'm going to use the second derivative test now to figure out what that critical point is, because we have the second derivative from part A. So d squared y over dx squared at the point 4, 2, well, 2y cubed will be 2 times 2 cubed minus y squared, which is 2 squared, minus 2 times x, which is 4, times y, which is 2, all over x squared, which is 4 squared. 2 times 2 cubed is 2 times 8, which is 16, minus 2 squared, which is 4, minus 2 times 4 times 2, which is 16, all over 4 squared, which is 16. 16 minus 4 is 12, minus 16 is -4 over 16. We don't need to simplify it. My instinct still makes me want to do it though. -1/4. So now we know it's a critical point. We know the second derivative is negative. So by the second derivative test, It's a long word. Since dy dx equals 0 and d squared y over dx squared is less than 0 at the point 4, 2. Hi, Paige. I'm finishing up a problem. G has a relative maximum at x equals 4. This is calculus, Paige. Do you like calculus?
Yeah.
And there is our answer, and we're all set.